Section 11.4.3, we want to be able to find the critical values of a two-tailed test with alpha equals 0.10, degrees of freedom in the numerator is equal to 15, and degrees of freedom in the denominator is equal to 12. Okay, so as this is a two-tailed test, there are two critical values to find. Okay, so because it's a two-tailed test, we're going to have to use these particular formulas here. Okay, here's the first one. This is going to be the left side of the drawing, which we'll see once we complete this problem. But first thing is first, since this is a two-tailed test, right, and we know alpha is equal to 0.10, well, we know that alpha is equal to 0.10, okay, and then we need to take alpha and we need to divide it by 2. So 0.10 divided by 2 is going to give us 0.05, okay? And then we also need to find out what happens when we take 1 and then subtract alpha divided by 2. So 1 minus 0.05 is equal to 0.95. Okay, so what that does is now that allows us to be able to then find the following. So I'm going to go ahead and take this formula again, and I'm going to copy it here, and I'm going to follow along here. So what does that tell us? Well, we know that we have f, okay, and then we have 1 minus alpha divided by 2. So 1 minus alpha divided by 2 is 0.95. We also know that the degrees of freedom in the numerator, okay, is 15. So we know that that is 15. And then we know that this is 12, which is degrees of freedom in the denominator. And what that equals is the following. It's going to be 1 over, okay, we have f, and now that becomes alpha divided by 2. Okay, well, what is alpha divided by 2? It's 0.05. We're going to go over this again, 0.05. And now the first number now becomes the degrees of freedom in the denominator. So now this becomes 12. And then this becomes 15. So let's go ahead and review that again. So what do we know? We know that here 1 minus alpha divided by 2 is 1 minus alpha divided by 2 is 0.95. We have 0.95. Okay. And then we also know that n1 minus 1 is the degrees of freedom in the numerator, which is 15. And that ends up changing and being the last one here, 15. Okay? And then we have the degrees of freedom in a denominator. So this one becomes 12. And so therefore now the 12 becomes the beginning. Okay? And then also, we also see that this alpha divided by 2 is 0.05. And now we're using 0.05. So now what we need to do is now we need to focus on finding this critical value here, or the F distribution critical value. So now what we're going to do is we're going to come down here, we're going to take a look at the chart, okay? All right, and so now that we have that, okay, we know that the degrees of freedom now in the numerator is going to be 12. And we know the degrees of freedom in the denominator is going to be 15. So now we're going to go ahead and then make our connection with 12 and 15, and we can see that the value that we end up getting is the following, which is 2.48. So now that becomes what we get in the denominator. So this becomes 1 over 2.48. And now we need to simplify this on our calculator. So let's go ahead and do that. So we're going to take 1, we're going to divide that by 2.48, and then we get the following number here. So I'm going to go ahead and copy that. Okay, so here is our value. But now what we need to do is we need to round it to 2 decimal places. So if we approximate this to be 0.40. Okay. All right, so next, now we need to find the other value. So we're going to look at the second formula here. And again, because it's a two-tailed test. So let's take a look at that. Okay, so for 3, okay, we know that this is going to become f, which is alpha divided by 2. We know alpha divided by 2 is 0.05. Okay, and then we know that the degrees of freedom in the numerator is 15, and the degrees of freedom in the denominator is 12. So now what we're going to do is the following. We're going to be able to now find the degrees of freedom in the numerator is 15, degrees of freedom in the denominator is 12. So if we take a look here and there, we end up getting the following value, which is 2.62. Okay, now that we have our numbers, now we should draw the distribution so we know what it looks like. Okay, so if we draw the distribution, that means we're going to have the following picture. We have a curve that is skewed right. Okay, and we have two values. We have two values that are critical values. We have 0.40, and then to the right we have 2.62. So this represents the left hand, and this one represents the right hand. And then we should also realize here that these and that right there, okay, the red here, they both represent the critical region.